In the last video, we looked at how to find the LCM, or least common multiple. And I mentioned then that if we're dealing with addition or subtraction of fractions or rational expressions, we would be finding the LCD, or the least or the lowest common denominator. They're pretty much the same thing as far as the calculations go. And most of the operations that you use in basic arithmetic are the same that you would use when you add or subtract rational expressions. We'll look at an example. Let's suppose you wanted to add, say, 2/3 and 5/4. And then from this we're going to subtract 1/6. So we have addition and subtraction in the same problem. Well, you should know that to add or subtract fractions you have to have the same denominator. So that's where the LCD, least common multiple, lowest common denominator, come into play. So here we're dealing with fractions, so we call it the LCD, or the least or the lowest common denominator. Now, with numerical expressions, you're able to, just by sight, figure out the LCD. So example here, if I factor out the denominators, here I have 3 in the first denominator, and then the next one is 4, or 2 squared, and then I have 2 times 3 for 6. So from that we can see that the lowest common denominator is 12. Now I could make each denominator then 12 by multiplying the numerator and denominator by the same thing. Or I can just do this type of procedure and say, okay, this is going to equal to, and obviously I want to come up with one fraction with the same denominator. So everything's going to be 12 here, so I'm going to put 12 here. And I could do something like this and say, well, 3 goes into 12 4 times, so that means I would multiply the 2 by 4. What is this times here? Plus, and then 4 goes into 12 3 times, so the next one will be multiplied by 3. It's 5 times 3. Then minus 1. 6 goes into 12 2, so that would be multiplied by 2. And notice if I write this as 2 times 4 over 12 plus three separate fractions, plus 5 times 3 over 12 minus 1 times 2 over 12, that's the same thing, or equivalent to what I have on the left side. Because all I'm doing is multiplying the first fraction denominator by 4, and 4 on top. So 4 over 4 is 1. So I multiply by 1. That doesn't change it. So that just gives me 8 over 12. Here I'm multiplying by 3. 3 times 5 is 15. 3 times 4 is 12. Over here I'm multiplying by 2. This will be 2 and 2. So there'll be 2 over 12. That's the same thing. Okay. So I have the same denominator. So now if I combine this, now I can add this stuff. So this is 8 and 15. 23 minus 2, that's 21 over 12. And then of course we have to simplify. So the numerator factors out into 3 times 7. The denominator factors out into 3 times 2 squared. And obviously we have a factor of 3 common, so we divide out the 3, so that leaves me with 7 over 4. So we always want the answer in simplified form. And even though this is an improper fraction, I'll just leave it like that for now, but it is reduced. 7 and 4 do not have any common factors. Well, we can do the same sort of thing with algebraic expressions. Either individually multiply the numerator and denominator by whatever it takes to get the same denominator, and then combine. So in this next example, it says perform the indicated operation and simplify the result. Okay, so you have 2x squared minus 4 over 2x plus 3 plus x plus 3 over 2x plus 5. Obviously in this one the denominators are the same. So all I have to do then is add the numerators. The denominator will stay. (2x) plus 5. And then the numerator becomes, then adding, I'll get 2x squared okay, x is by itself, so this will be a plus x. And then minus 4 and a plus 3 is a minus 1. And then the last things you try to do is you try to factor this thing. Okay. So it's a trinomial. The GCF is 1. The only factors of 2x squared are going to be 2x and 2x. The factors of 1 are going to be 1 and 1. And then we try to factor this out. Doesn't factor into anything that's going to reduce out. So in this case, this is the answer. Okay. So 2x squared plus x minus 1. And the next one, we have the expression, rational expression, x over 2x minus 2 plus 3 over x squared plus x minus 2 minus 1 over x squared minus x. So again, in order to find the LCM, or in this case LCD, we want everything in the denominator factored out. So the first denominator, 2x minus 2, factors into 2. Take out the factor of 2. Get 2x minus 1. And then the x squared plus x minus 2 in the second denominator factors into x minus 1, x plus 2. And in the third denominator, I can take out a factor of x. I get x times x minus 1. So now for the LCD, which is what I have on the right side, for the LCD, I take all the different factors that appear in each of the denominators, the most number of times they appear in each denominator. Okay, so in the first denominator I have a factor of 2, so that has to go over here. That's where I get that 2. Okay, and then x minus 1 is a factor. I put it down, x minus 1. Remember I put out all the different ones that appear. And then x plus 2 appears, x plus 2, there it is. And then the x factor. And then if this had been, say, an x squared, then I would have an x squared here. Or if this x minus 1 had a 2, I'd put a 2 in the x minus 1 over here. Okay? So you always take each different factor that appears in the factorizations of the denominators, the most number of times they appear. In this case, the most they appear in each denominator is 1. So each of these has a power of 1. And that would be it. Okay. So then if I do what I did with the numbers, I would simply say, okay, for the first fraction, I would take the denominator and divide it into this. And then what I have left, I multiply the numerators. Okay, so okay. 2x minus 1 divides into, well, you can see the 2 and the x minus 1 are going to cancel. And I'm going to have left x plus 2 and a factor of x. So that's going to multiply. That's going to multiply the x. All right. So again, let's go to this view here. So 2 into this denominator divides out the 2 and the x minus 1, leaving me with x and x plus 2. So that multiplies the x. In the second denominator, the x minus 1 and the x plus 2 divide, leaving me 2x. So the 2x multiplies the 3. And then the x and the x minus 1 divide over here, leaving me with 2 and x plus 2. So that multiplies to negative 1. Okay, so notice it's the same thing as coming over here and looking at this first denominator and say, okay, this denominator has a denominator of 2x minus 1. In order to have the same denominator, I need factors also of x and x plus 2, so I would multiply the top and the bottom by that. But that gives me the same thing that I have over here. Okay, looking at the second one, it has factors of x minus 1 and x plus 2. I'm missing the 2x, so I would multiply by 2x and 2x, but this gives me the same result. And then in the third denominator, I have a factor of x and x minus 1. I'm missing the 2 and the x plus 2, so that's what I multiply by. Okay, so this is equivalent then to going through this procedure over here. And then I just multiply the expression on top. So the x, this x times x is x squared, multiply through there, I get x to the third, plus 2x squared, and then 2x times 3 is 6x, and then over here, minus 2 times the x plus 2 gives me a minus 2x minus 4, and this is not going to factor out any further, so that gives me my answer. X cubed plus 2x squared plus 4x minus 4 over that denominator. Okay, so this is basically the procedure that you can follow when you're adding or subtracting rational expressions. So make sure that before you start, each denominator is factored out completely. That will allow you to find the LCD, and then you just follow this procedure. Okay, so we'll check you out in the next video.